equations with more than one variable. And we're only going to talk about equations with two variables today. So the reason we have equations with two variables is usually to generate a graph. So you put one value in, you get another value, you get an ordered pair from that, and you can create a graph. We'll just walk through step by step, and you could stop me at any time and ask if you have a question.
Okay. Can you just hold on for a second, please?
Sure can, Natasha. Yep.
I need to make some room here.
Time. Hi, Chris. Okay, Chris was on. He left.
Make some room. Take down some notes. Sorry, I'll be right back. I got the wrong book.
Okay, Natasha. Sure, take your time.
Okay, that's the wrong book.
So in this lesson, we're going to be working on equations that have more than one variable. And we're going to take a look at how to solve them after giving an explanation of what the two variables are. And then taking the ordered pair that comes out of this, out of solving for the two variables, making them into a graph. The two variables become what's called an ordered pair, and that ordered pair can be used to generate a graph. Very basic foundation of graphing, which becomes a lot more complex as you move along in higher math. Now we're just waiting for Natasha. She's going to take some notes from this session, and we're also going to work on some examples.
I'm on my way. I'm coming.
Okay.
Okay, here I come.
Okay. We're going to continue on here with starting with an explanation.
Okay, I'm good now.
I was just saying some things because of the fact it's recording. I'm just kind of going over my notes here. Okay. So you can see my screen okay?
Almost. I need to close something out here.
Okay.
Okay, I can now.
Okay. So digging into this idea of an equation with more than one variable. So in this case, we have two variables. And as the description shows here, you have a dependent variable and an independent variable.
Mm-hmm.
And so I kind of call an equation like this with two variables, it's kind of like a machine.
Mm-hmm.
In the machine, you put a value on one side, that's your independent variable. In this case, it's x. And the independent variable is usually on the side that has other functions, like 2 times x plus 4.
Mm-hmm.
On the other side, when you put the 2 in, on the other side of the machine, you get out the dependent variable. And the dependent variable is always shown as by itself.
Mm-hmm.
And It's by itself because when you put something in for the dependent variable, do the calculation, you're going to get out the dependent variable. Okay?
Mhm.
That'll make a lot more sense when we get into an example here. So this is an example. Y equals 2x plus 4, and for every value of y, it's dependent on what you put in for x, and it'll make a lot more sense when we get into it. So to solve the equation, you follow two steps. First, you choose values for the independent variable. It's independent because you're choosing it, and so that is your x. And when you choose those independent variables, put it into the equation, you're going to get out the dependent variable, which is y. Okay?
Mhm.
Okay. So the first couple of problems here really are only going to help you to identify which is the dependent and which is the independent variable. So I'm going to my pen. Hopefully you're going to be able to see that. So in the first problem here, it is y equals 4x. And so it's asking which is the dependent and which is the independent variable. You want to take a try at that?
Yeah, I'm trying to find my pen or something to write with.
Okay.
Yeah, hang on. I got one. Yeah. Could you hold on a second, please?
Yep.
I'm hot. This ain't working.
So as Natasha is getting her pen, we're going to take a look at three samples here of identifying the dependent and the independent variable. And again, the dependent variable is going to be by itself, and the independent variable is going to be on the side of the equal sign that has some kind of function. In this case, it's 4 times x. In this case, d and t, and it's 45 times t plus 30. Independent. In this case, we switch over to c and n. 75 cents times n plus $1.20.
I'm all set.
Problem A here, we have y equals 4x. And so as I mentioned before, the independent variable is going to be the one that has some kind of function to it. The dependent variable is going to be by itself. So in this case, we want to take a try at which is the dependent variable. So the dependent variable is always going to be by itself. If you put something in for the independent, you get out the dependent. Make sense?
No.
Okay. All right. No, that's fine. Okay. So you have an equation, equal sign. On one side of the equal sign, you have a function. On the other side, you have the answer. On the function side, that's always going to be your independent variable because you're able to put in any value you want for that x. So in this case, your independent variable is x. Now, when you put an amount in for that x, multiply it by 4, you're going to get an answer on the other side, and that answer is dependent on what you put in for x. So in this case, the dependent variable is y. Yeah.
Okay.
Okay, so then moving on to B, instead of x and y, we have d and t. So the side of the equation that has a function, which is 45t plus 30, you can put any amount you want in for t, and when you do, you'll get an amount out for d. So d is dependent upon what you put in for t. So your independent variable is going to be this one, t, And your dependent variable is going to be d, because whatever you plug in for t and multiply it by 45 and then add 30, that's the answer you're going to get, and the answer is the dependent variable. In this case, it's d.
Okay.
And then moving on to this one, it has
Can we go back to B? Is that 45R? I can't see that.
that's a t.
Oh, that's a T.
Yeah,
And that's plus 30 or divided by?
plus 30. That's a little light.
Yes, it is. Hard for me to see that one.
Okay, it'll get better.
Okay, and then the other one is C equals,
It's a dollar sign, so dollar sign 0.75 n plus dollar sign 120.
N plus $1.20.
So all this problem is asking us to do is determine which one is the dependent variable and which one is the independent variable.
Okay.
So the independent variable is always the one you're
D?
that's the C is going to be the dependent variable. Yep.
C is dependent. And the independent variable is going to be N.
Yes, very good. So it's like, I know it's again, it's a little bit hard to see, but that's the right answer.
It really is. Okay.
Okay, so now we understand dependent and independent variables.
Mm-hmm.
And so we'll move on to try to solve some of those, okay?
Okay.
So first I'm going to erase that. You can see my writing here, right, in the blue?
Yes, I can. That blue helps. That does work.
Okay. So first I'm going to erase that, and then I'm going to move on to the next page before I
Would
can
you
do that.
happen to have any of these
What's that?
variables?
Probability?
Yeah, probability. I'm sorry.
What about it?
Do you have this pamphlet?
No. Today I was only gonna be working on equations with two variables, but I will have an open table session at 10:30. I could help with that then.
Okay.
Okay. All right.
I'll be here.
Okay. I'll be happy to help you with that. So this hour is strictly trying to record a specific lesson, and
Okay.
then the open table sessions is open to work on whatever you'd like to work on.
Okay. All right.
So we'll continue on here. Now we'll do some examples. All right, so we're trying to solve for the dependent variable here. Now, this problem here, in case you can't see it, is y equals 3x.
Thank you, because I couldn't see that.
Right? Okay, so and they're telling you that for this problem, let's let x equal 2. All that simply means, Natasha, is that if x equals 2, we're going to substitute the 2 in for the x, and we're going to have an equation that says y equals 3 times 2, right?
Right.
Which is 6. So the answer to the first problem is very simply y equals 6. So we have an equation with two variables, y equals 3x.
Mm-hmm.
If we allow or plug in 2 for the x, we end up multiplying 3 times 2 and getting y. Mm-hmm. So the answer is for every time x equals 2, y equals 6.
Okay.
Okay?
Okay.
Move on to the next one, which is, and I'm going to write it out, and I'm going to change the color here because
A equals 5 something.
you see that? I'm going to choose a different color. I'm going to go red. Okay. It's A equal.
No, I see your blue. It's their writing. The problem out is what I can't see.
All right, you want me to stay with blue?
Yeah, that's fine.
Okay. Okay. A equals 5B minus 6. And they're telling you here that let's let B equal 0. So if we let B equal 0, we still go back to our equation and say A equals 5 times 0 minus 6. And just solve that equation. So we know that we do multiplication before subtraction. So we're going to do this first. 5 times 0 is 0. 0 minus 6 is negative 6. So when I have this equation, A equals 5B minus 6, when B equals 0, then A equals negative 6. Understand how I did that?
Yes, I do.
Okay, great. Okay, moving on to this one, the third one here. Can you see it, or you want me to write it out in blue?
I see C equals $1.50, right?
Yes.
$1.50.
I'll straighten it out.
Yeah, I don't see that. I don't know what that little letter is.
Okay, that's fine, Natasha. $1.50
plus $1.10.
Yeah, so that's an N.
Oh, that's an N. Okay.
Yeah, $1.10.
It says if N
Equals 3.
N equals 3.
So what we want to do is plug in that 3 for the N.
Okay.
C equals $1.50 times 3 plus $1.10. Just multiply that out. You want to do it on a sheet of paper, or do you want me to?
So that's C. The C equals $1.10. I mean $1.50 times 3
Yes, plus $1.10.
plus $1.10. We're gonna do multiplication first, right?
Correct. So $1.50
$1.50
times 3. Let's do it longhand here. We got 3 times 0 is 0.
50.
What'd you get?
I got $4.50.
Right. Right. So we got 450 plus $1.10
$1.10.
is going to be
$5.50. I mean $5.60.
correct. So your answer is $5.60. So going back to this equation now, C equals $1.50 N plus $1.10. So when N equals 3, then C equals $5.60. Okay.
Okay.
Now I'm gonna do a couple more examples that I have over here. Okay.
Okay.
So for the first example, it's y equals, and I'm gonna go negative here, negative 3x plus 4. You can see that, okay?
4. Yeah, that come in real good.
Okay, because that's the one I did myself. That wasn't from the text.
Oh. Okay.
So what we're gonna do is we're gonna start out with letting x equal 2.
Okay.
Okay, so if x equals 2, we have y equals negative 3 times 2 plus 4.
4.
Okay.
I don't know why I want to keep putting y equals 6 plus 4.
Well, you're close because negative 3 times 2 is negative 6. Negative 6
Plus 4
plus 4. And that equals,
is 10.
no, because it's negative 6 now plus 4. So negative 6 plus 4 is negative 2.
So
Right?
you divide it?
No, what I did was, so if you're on a number line, and here's negative 1, 2, 3, 4, 5, 6. You're at negative 6, and you're adding 2, you're going to the right. I'm sorry, if you're adding 4, you're going to the right. 4 spaces, that takes you to negative 2. Okay?
Okay.
All right. So your answer is,
Negative 2.
yeah.
Okay.
Okay, I'm gonna, can I erase what I have here?
Sure, I got it right on paper.
I'm gonna erase that. So now let's try 3. So y equals negative 3 times 3 plus 4. So negative 3 times 3 is negative 9
Right.
plus 4. So again, let's look at it like we're on a number line. Here's 0. There's negative 1, 2, 3, 4, 5, 6, 7, 8, 9. We're at negative 9. And if we're going to add 4 to negative 9, we're moving 4 places to the right. 1, 2, 3, 4. And that's negative 5. Okay, so your answer is negative 5.
5.
Yep. Okay,
Uh-huh.
get rid of that. I like this writing tool, do you?
Yeah, I do. Kind of neat.
It really helps. Okay, I'm going to do,
It has came a long way.
yes. I just discovered it when I started using the go-to meeting. I looked up at the top here and it says drawing tools. I thought, well, let's give that a try.
Mhm.
And I clicked on it. Oh, this looks pretty easy to do. So y equals negative 3 times 7 plus 4 equals negative 21 plus 4. So if you, again, you do that number line, you're all the way over here at negative 21, and you're adding 4. 1, 2, 3, 4. So that's negative 21, negative 20, negative 19, negative 18, negative 7.
17.
Yeah, negative 17. Okay?
Right.
Go to erase that. Can I erase that now, Natasha?
Oh, sure you can. I got it on paper.
Okay, let's get rid of that and move on to the next example. So that's y equals 1/2 x minus 5. Let's just try the 6. So
Now, that's hard. That's a hard one.
I know y equals 1/2 times 6 minus 5. 1/2 times 6, can you do that?
3.
Equals 3 minus,
Oh, that was right. Oh,
yeah, you're right, and that's negative 2. Right?
that's
You
3
got that. Okay,
minus 5.
all right.
2. Uh-huh.
Okay, let's get rid of that.
Okay.
Let's do the 8. So if I plug in the value of 8 for x, I have y equals 1/2 times 8 minus 5 equals, so 1/2 of 8 is 1/2 times 8. What's
4.
half of 8?
4.
4 minus 5 equals
1.
-1. -1. Okay.
All right.
All right.
Mm-hmm.
So let's move over to one more example here. We got y equals 5 times x. And we'll plug in, let's plug in 7. So y equals 5 times 7.
7 times 5 is 35.
There's your answer. So when x equals 7, y equals 35.
Okay.
Okay. Good enough? We'll move on.
Yes.
All right, so I'll get rid of this. And I'll move on to the next page now. Get rid of my pointer.
I don't want all of that.
All right.
I told you.
So now, Natasha, what we're going to do is we're going to do several variables for a problem, and then we're going to fill in this table here. And when we fill in this table, we have an x and a y. And when you have an x and a y, that gives you something called an ordered pair. Those two numbers together are called an ordered pair. So in case you can't see that, it's y equals 6x. The first value we're going to plug in there is 0. So y equals 6 times 0. And anything times 0 is going to be 0, right?
Right.
So when x is 0, y is 0. Next, we're going to plug in y. We're going to plug in this 1. Y equals 6 times 1, which is 6. So when x equals 1, y equals 6.
Y equals 6 times 2. It's 12.
No, yep. Yep. And then 3.
18.
Okay, very good. So now what you're going to have is you have 4 sets of what I call ordered pairs. So
Okay.
my x and y here, so are going, when you write an ordered pair, you do it with a parentheses. So the ordered pair for this function is 0, 0, which is here,
0,
and then 1, 6,
0, 6.
1, 6, and then 2, 12,
0, 6,
and finally
2, 12.
3, 18. Okay?
Yes.
So this function, y equals 6x, when I plugged in these 4 values, it gave me these 4 sets of ordered pairs.
Okay.
And what we're going to see on the next page is that you can take those 4 ordered pairs and you can create a graph from them.
Mhm.
But before we do, let's do one more example here. And that y equals 1/2 x plus 2 times 1/2, which is just 1. 2 plus 1. 1/2 x plus 1, rather. So when y is 0, I have 1/2 times 0 plus 1, which is 0 plus 1, which is simply 1. And then when I have y equals 2, I'm sorry, when I have x equals 2, I have y, I'm plugging in the 2. I have 1/2 times 2 plus 1, which is 1/2 of 2 is 1. 1 plus 1 is 2. So I've got, and then when y equals 4, I've got 1/2 times 4, which is 2, plus 1 is 3. And then when y equals 6, I've got 1/2 times 6 is 3, plus 1 is 4. Make sense?
Mm-hmm.
So my 4 ordered pairs here are 0, 1, 2, 2, 4, 3, and 6, 4. And it's only going to be important when we do the graph.
Okay.
All right. So you see now, just to review on this page, we had two functions,
Mm-hmm.
2 variables. We plugged in the independent to get a dependent. These are the independent. We got a dependent, and we have 2 sets of ordered pairs. And the ordered pairs, you have an independent on the left, dependent on the right.
Okay. Got it.
Beautiful. Okay, so I'm going to erase that and move on to the next page. Okay, so Natasha, did you write down those 4 sets of ordered pairs?
I sure did.
Okay, so tell me the first one.
The first order pairs I got 0, 0 dash 0.
Okay, so let's plug that one in. 0, 0 is right here.
Okay.
0 on the x, 0 on the y. And then the second one was?
1, 6.
Okay, so I go 1 over 1 and up 6.
And then I got 2, 12.
Oh, okay, that's going to be way up here, so that's too big for this graph. But if I have two ordered pairs, I could still draw a graph between those 2 lines. So 2, 12 is going to be way up here somewhere, and it's going to be right on that line.
Mm-hmm. And then I got 3, 18.
Okay, and then so 3 would be way, way up there, and that would be it's just a straight line graph.
Okay.
So let's do the second one. Then I'm going to get rid of that.
My next pair I got 0, 1.
That's right here. So over the 0 and up 1. So 0, 1.
I got 2, 2.
So over 2, up 2.
Mm-hmm. I
And
got
then
4, 3, and 6, 4.
4, 3.
Yep, and 6, 4.
So if I had a ruler, I can make a straight line, but I don't.
Mm-hmm.
But I can illustrate here that those ordered pairs gives you a straight line graph. So if I go back to the previous problem, what we're showing here is a graph of the equation y equals 1 half x plus. So this graph is a graph of this equation. So whatever x I put in there, I get the value of y that is 1/2 x plus y. So anywhere along this line, if I plug in any of these numbers, I'm going to get whatever answer I get when I plug that x into this equation.
Okay.
So just to show you that if I put in 3, 1/2 of 3 is 1.5. 1.5 plus 1 is 2.5. So when I go over on this graph to 3, I should go up 2.5 and be on that line, and that's where it is.
Okay.
Make sense?
Yes, it does.
So Natasha, this is called a Cartesian coordinate.
Wow.
It was founded by a scientist by the name of Descartes.
Mm-hmm.
I'm not sure how his name got from there to Cartesian, but whenever you hear the term Cartesian graph, it's the x over here and the y here. The x is the horizontal, the y is the vertical.
Okay.
And take the ordered pair and you move over that many for the x, and you move up or down that many for the y. So if y had a negative value, you'd go down.
Mm-hmm.
Okay, so I will erase that.
I haven't that blank.
Erasing that. And I'm going to move on to my next page.
Blanket. Turn the light back on. Blanket.
Okay, this is just a fun page. You don't have to really do anything other than this is showing you that there's this kind of a fun website called Math is Fun.
Mm-hmm.
And in this website, Math is Fun, they have a lot of different ways that explain what the Cartesian graph looks like. And I just kind of pulled that up here. And this is a sample of that website. This is not necessarily part of the lesson, other than the fact that if you go to this website, mathisfun.com,
Mm-hmm.
you can kind of play with Cartesian coordinates, and there's a couple of games in there that help you to plot x and y and make graphs.
Okay.
The beautiful thing about this is that there's a game here called Play With It, and if you do that game, it allows you to enter at any level that you want. So for someone just starting out, you might want to go with a lower level, plug that in, and then when you get proficient with it, move on. It's just kind of a fun way to learn. Math is fun. I just happened to find it on the website when I was preparing the lesson on Cartesian coordinates. So I will go back to now my lesson and just try a couple more, okay?
Okay.
So go back to getting my pen, and this is a little more complicated than the previous one. We've got y, you can see that, y equals 2x minus 5.
Yes.
So I'm going to plug that in for the x values, which are given here in this table. Y equals 2, and for the x, I'm going to plug in 1 minus 5.
Which is 10. Oh, no. No.
It's 2 minus 5. So 2 times 1 is 2, 2 minus 5 is
It's
-3. -3. 2 minus 5.
-3. 5.
So when I plug in y equals 2 times 2 minus 5, that equals 4 minus 5 is -1.
-5.
-1. And
Okay.
when I plug in 3, I've got y equals 2 times 3 minus 5. 2 times 3 is 6 minus 5 equals 1. And then finally, when I plug in 4, I've got y equals 2 times 4. I'll use the parentheses to keep it neat. Minus 5. 2 times 4 is 8. Minus 5 is 3. Got it?
Trying to write these notes down. What
Okay.
is right here by the, I don't know what that is.
Where at?
Is that y minus 2, 4?
Yeah,
Next.
y equals 2 times 4 minus 5.
Oh, that's 2 times 4. Okay.
Because I'm plugging it into this original equation here, see?
4 times 4, -5. Okay. And then you said 8.
Yep.
8 What is that,
Minus,
8 times?
that's 8 minus 5 equals 3.
Minus 5.
So now from this table of values, I have generated 4 sets of ordered pairs. And those ordered pairs are 1, -3, 2, -1, 3, 1, and 4, 3. Now, if I were to take those 4 sets of ordered pairs and put them on a graph like I did for the previous equation, I would create another straight line graph.
Mm-hmm. I think so.
Got it?
Yes.
And it's as simple as that. And if it's the same with this problem, I can plug in these values for B and come up with a dependent variable A. Same thing. I think I had. Okay, you're good with this? I can erase that?
Okay, because I can't see that first number.
Which one?
The problem that you got circled around?
Oh, yeah. Let me get rid of that.
Yeah,
So
that.
A equals 2.4 equals,
That's an A equal 2.4?
yeah, B minus 1.6. And it would be the same. Do you want me to go through the table on that? Do you want me to plug in all 4 of these values for this equation? I could do that.
Okay. Sure.
Okay.
Yeah.
So the first, let's plug in 0. 2.4 times 0 minus 1.6. So 2.4 times 0 is 0. 0 minus 1.6 equals -1. So when B equals 0, A equals -1.6.
Okay.
All right, now let's plug in 1. So A equals 2.4 times 1 minus 1.6. 2.4 times 1 is 2.4. 2.4 minus 1.6. 6 from there is 0.8. So your answer is 0.8. Now I'm going to plug in 2. I'm just going to write it over here where I have some space. A equals 2.4 times 2.
That's the letter A?
Yes,
Okay.
minus 1.6. So that equals 2.4 times 2 is 4.8 minus 1.6. So let's go over here and write 4.8 minus 1.6. 8 minus 6 is 2. 4 minus 1 is 3. My answer is 3. 7.2. And finally, 3. I think I can write over here. So A equals 2.4 times 3 minus 1.6. So 2.4 times 3, let's figure that out over here. 2.4 times 3. 3 times 2 is 12. Carry the 1.
I got 7.2.
Correct. 7.2.
Uh-huh.
7.2 minus 1.6 equals
6. Nope, that's not right. It's always going to go behind the decimal, right?
Yep.
1.
So let's do this. 7.2 minus
16.
1.6. 6 from 12 is 6. You gotta make that a 6. 6 minus 1 is 5. You borrowed the 1 there. The answer is 6.5. I mean 5.6.
I'm with you.
5.6. So now we have 4 more ordered pairs, and those are, I'm going to change the color on this
Okay.
red. So we have the 4 ordered pairs here, which is 0 and negative 1.6. And then just copying this down here, we have 1 and 0.8. And we have 2 and 3.2 and 3.2 and 3 and 5.6. Okay, those are your 4 ordered pairs.
2.3.
Now, if I were to take these 4 ordered pairs and put them onto a graph, it would give me a straight line graph, much like I did with the others. Okay?
Uh-huh. 6. Okay.
Are you all good with that now?
Yep, I got my notes together. Yep.
So I'm going to erase that.
Mm-hmm.
I do have, let's see, I do have, kind of running out of time, but I do have a couple more. It's the same thing. I don't think I'm going to go through all these, but it's the same process.
Okay.
So plug in the 0 for the t, multiply it out, add it, an answer. Plug in the 1 for the t, multiply it out, add it, get an answer. You do all 4 of them, you have 4 ordered pairs, and you can graph that.
Okay.
And the same over here. 25 cents plus n. When n is 2, you plug the 2 in for the n, and you add the 32, and then you get a value for c. Same for 4, you plug the 4 in for the n and multiply it by 25 cents, add 32 cents, then you get a value for c, and you'll have 4 pairs. Okay?
Okay.
So that is the nature of multivariable equations with 2 variables. I'm just gonna go back real quick to my opening page. So we see why we have equations with 2 variables. We generate a graph. We solve them by plugging in a value for x and getting a value for y. Did several examples, and then we graphed those examples. And that's pretty much going to be it for today.
Okay.